Three, two, one, here we go. So, hi, today is day 2 of DSA learning, and here we will start again. Yesterday, I just made mistake, and due to that, I uploaded partial video, or you can say, whatever I uploaded, it was completely like without a screen recording. So, problems. So, today I'll take care of it, and while I will edit video, at the time I'll club both. And today iPad is also working, so luckily the cable that I use for charging also got connected. So for the first time it worked. I don't know what, maybe something God is with us. So okay, no bakwas. Let's actually as today I'm planning to complete the easy section where we have questions. So not sure if I'll be able to finish all the questions, but we'll target for all. Like we'll target to complete all. So okay, this is stage 2 of DSA learning. So let's begin, guys. Let me start. Command Shift F. No, Command Shift 5. 5. 5. 5. nahi. I thought I'd not speak even a single word, single Hindi word, but still. Okay, so we are in the array problems, and let's start with. So yesterday we solved we tried to solve all 5 problems that are very basic, and now we can move to easy section, and our pattern would be something like first we will solve it on paper, and after that I'll code over online ID, and here we are going to use take you forwards ID. So let's start with maximum consecutive ones. Let's see what is the problem. Actually, I might have solved it in past, but not sure if that is perfect or I made mistake. Even I don't remember the problem exactly. Maximum consecutive and arrays are there are so many array problems, and I always face challenge when I try to approach the problem. Count maximum consecutive ones in the array. Oh, where am I? Solve, not tutorial. We don't need, at least for now. I can't. Okay. Look, today's day 360, and targeted. I made a target of 30 days, so it's like so many months, more than 12 months. I have surpassed or so. Given a binary array nums, that means there will be zeros and ones. Return the maximum number of consecutive ones in the array. Consecutive ones in the array. So okay. So for example, we have we have ones, 1 0 0 1 1 0. I don't know how to write over a screen, so maybe let me note down example first. 1. Okay, I think this one is easy. 1 1 0 0 1 1 1 and 0. So total. Okay, let's see the constraints. What are the different constraints used here? So we can return 0. Okay, everything is okay till now. All the numbers will be 0 between, okay, either 0 or 1, and length can be between 1 to 10 raised to power 5. So can I say what I can say? Okay. Here we don't know what will be the length of, how much max length of list. So let me switch the screen to see the values. Yeah, so here we go, and we have a number. So what I will do, I'll simply what I'm thinking to do. First, I'll try to find out first So let me write down the step. Try to find the first number. Is it okay? If I'll try to find out the first number, and after that, maybe let's say this one is the first number. So we found it. Then we'll make. So after that, we will start traversing the numbers, and we'll see if another number and active equals to true. Why do we need first number? Okay, what I'm thinking, we don't need all this bullshit. We can track it directly with the help of a flag that will be initially false. And so in the flag we'll track basically whether the number we have continuous numbers or it is first number after breaking the continuity. So at the starting we don't know whether, or we can say like we do not have any continuous sequence of ones. So we can say flag is false and we'll track with first number. First number, if flag is false, so simply we can make it true, and max length will be nothing but will store max value as 0. That means we don't have any length. And now we can say max of existing max, and we can say okay, okay, and we need to have another variable that I can say count, that will be 0. Count plus equals to 1 plus equals to 1, and I think I'm unable to explain it properly, so let me retry to explain it. So what I'm thinking, first thing we'll take a flag variable that will be nothing but it is going to store whether, let me open timer as well, otherwise I'll take too much time to solve a single problem and won't be, it's not going to benefit me anyhow. So shall I open timer or leave it? I have option directly here, so maybe let me take 25 minutes of duration for to solve this problem. I think we have timer option is there only. Yeah, no. Okay, let me see it. 30 minutes. Let's take, and okay, 30 minutes. Let's target it to. So I'll try to explain it first, so that if I'm assuming you are an interviewer and I'm just trying to explain the problem or algorithm before approaching to solve this problem. So here what I'll do, first thing I have to basically store somewhere to track whether I have continuous number before processing of, suppose I am at a number and I wanted to see, uh, I want to make decision at this number. So first thing I need to check if this is 0. If 0, then we can simply, okay, if it is 0, then there are two options. One is we need to check flag, and if flag is true we need to make it false. Okay, second also, okay, so we don't need to update the length, and we need to make count equals to 0. That means we don't have any continuous max length or previous. So yeah, so count is nothing but it is going to show you that how many contiguous ones are there in the past, ones are there in past preceding. So here what I'm thinking, we will be having flag, count, and based on flag and count we can decide and max, and we can update max. So let's iterate through it. So initially what we'll be having, flag will be false, okay, count will be 0, and max will be 0. We will be, now we are at first number, so let me change the color. First number, so what we are going to do, we have two options. If flag equals to 0, then if flag is equals to 0, then check, then make, okay, flag equals to false, and count make also 0. So we don't have any, whatever value we had in previous, we are going to reset it. So reset the value, and max, the only these two things needed to be done. If flag equals to 1, then okay, so count is nothing but plus equals to 1. So count, we are going to update the count, okay, whatever the value we had in previous in past, we are going to update it. Second thing, we have to update flag, okay. If count plus equals to 1, and max is nothing but max and cnt count, okay. So first time it will be 1, count will be 1, and max will be 0 and 1, so 1. Second number, we are going to move it to it, and again if flag equals to 1, not flag, basically here number, so that's why I need to solve these problems in the paper. Number equals to 1, then count equals to 1, okay. So here what we will do, we have 1, we have 1 in the past, now we have two ones, so count is not going to be updated, okay. What I'll do, I did a lot of mistakes, so let me see the time. I think I'm unable to explain it properly to you guys, so I'll try to improve it day by day. So because I don't know, I am unable to explain it in proper way. So okay, now what I'll do, I'll take max of 1, and in the second iteration we are going to take, we'll see number is 1, then we will update count plus equals to 1. So count we are going to update, so and then we are going to check max is nothing but max of existing max value and the latest count, okay, and so on. So it will be 2. Now we have 2 and we found 0, then simply reset count equals to 0, and I don't need flag, to be honest, okay. Count will be 0 and max is not going to update, okay. Then again 0, then count will be 0, we are going to override just count, so we don't need to check whether continuous or not. We already know we are calculating the count, so based on count we can decide whether the past value was positive or I mean 0 or 1. If there was a problem, something different, if this problem, if we can tweak this problem little bit, then the things will change. Like if we don't have zeros and ones, we have different numbers, then the problem will be different. Like we have to check and we need flag to use flag, okay, yeah, obviously. So we have idea, now we need to implement it. I think maybe in next problem I'll try to explain it in better way. So for the time being, what we'll do, we are in Python, and let's, okay, so let me do one thing first. First thing is nothing but count equals to 0, max, let's call it as a mx, and that will be 0. And now let's iterate through the numbers and for real in nums. Okay, great. Now if el equals to 0, that means we can simply reset count equals to 0, and okay, no need to do any other thing else. That means number is 1, and we can do one thing, max is nothing. Okay, let me do first thing, cnt is nothing but we are going to update it or upgrade it to +1. Okay, here we can do blindly, and count plus equals to 1. And now another thing that I need to do is what, do you know? Okay, so here we go, count plus equals to 1 and count equals to 0, and we need to update max. Mx is nothing but max of existing mx and whatever value we have so far, and count, if count is greater than that, then we need to update it or upgrade it. Okay, finally we'll get the result and we need to return it, nums. Now bro, try. Okay, okay. So it is working. Let me submit it, and after that we'll try to solve the we'll, okay. We can see it clearly. It's going to take order of n, complex time complexity will be order of n. If you remember, on 11th May to 2025, I solved these all basic problems, and now it's held 1 year and I'm attempting again. So that's the problem. If you are not doing something consistently, it's going to make you inconsistent. Exit focus mode, resume. Okay, bro, this is focus mode, then focus mode. How I'm going to approach another problem? I think, okay, this one is done. Now let's move to another problem. Nothing but move zeros to end. I know it very well. So we can assume, let me add a timer again, solve, and I'm expecting it to I'm expecting to solve it in within 10 or 15 minutes. That is too much time, as I already attempted these problems. So let's take target of 20 minutes. We will go slowly, we'll move slowly, and make we can will build concepts gradually. So here we have a problem where it is saying, they are mentioning like, given an integer array nums, move all the zeros to the end of the array, the relative order of the other elements must remain the same. That means, suppose we have 0 1 4 0 5 2. That means if we are moving zeros at the end, then 1 will be near to 4 and 4 will be near to 5. So you can assume like you are just basically you just removed all the zeros from the array, and you just compressed the array, so it become like 1 4 5 2, and just you placed all the zeros at the end. So we can assume like that. So there is one approach, we can pull out all the zeros first, and then whatever the numbers are, or you can say you whatever the numbers we have other than zeros, we can insert them into a list, and then at the end we can attempt we can append all the, or we can insert all the zeros. But we will, in that case we have to use the space complexity of order of n, and that is not an efficient approach. So here we need to think about it in a different manner or different approach. So let's let me note down the number and we'll approach it again with the same notepad approach. Okay, so got it. This time I'll try to explain it in better way compared to the previous one. I just messed up everything. Now this time what I'll do, I'll think and speak slowly, so I can think. Before speaking, I have to think in brain like what I am going to explain to someone. If someone is newbie, then or novice, or yeah, then so let me note down the example. What is it? Zero. Why it is 100, not 100%? 0, 1, 4, 0, 5, 2. Am I recording this screen or not? Okay, it is recording. Great. So here we have an example, and what is expected value? 145,200. So let's proceed with it. Proceed with it. Okay, let me open Notepad first. Okay, here we go. We have Notepad, and I noted the example. And so what we are going to do? We have numbers. Now I just want to place this number, this zero at the end, this zero at the end. So can I say at the end, and these zeros can be placed at the end, and we don't care where is the position of zero at the end. Like their orders doesn't matter. The only thing is we have to keep the order of these numbers, non zeros, to be same. I mean, 1 will be 1. After that, 4 will be there. 5 will be there. 2 will be there. Then 0, 0. So now the problem, or now how I'm going to approach this problem. So for that, or I'm thinking maybe what if we are going to if there is a number 0. Hmm? First number is 0. That means we can swipe it. What if I'll swipe this number with the neighbor post? Okay, first I got this one. 0 will keep fair. Second one, okay, what I'm thinking, maybe we can use two pointers here. First one will point to 0, or first one will point to the 0. Second one I have to look the number after 0. So it will point to this. Now we can swap them. So it will be 1 and 0. 4052. Again we are at it. So now we can say we are pointing to 0, and we can check 4. 4 is again, then 1, 0, 1, 4, and 0. 0, then we don't need to do anything. We need to find out another uh, swapping number. 5. So 5 to, now we need to swap this 0. So we'll keep with 5. So what I'll do, I'll swap these two numbers again. So it will be like 14500, and now we have to, again I am at 0, and we need to find out the pair non-zero number, and if there is anything then we can swap with it. So approach would be something like, first we need to find out a non-zero number, not no first we need to find out a zero, first zero, and after that we need to start scanning from that number to find a non-zero number. Okay, if there is anything then swap with it, and wherever we are going to swap. No man, something is fishy here. Okay, I think I'm not in the way. Suppose here what I'll do, we have black pen, it will be ugly. Hmm. Okay, sorry, my bad. So we are at 0. Find first 0. 0. Call it maybe I, index I. Then from I plus 1 to nums n, look for first non-zero. Swap with it. That means, so yeah, we have all the non-zero numbers before this swapped index. So we can move, or we can mm, advance the index of I to next index. So steps, let me note down the steps. First step would be something like find non-zero number, find 0. Second, start looking for non-zero. And when found non-zero, 0, then swap both and advance. So we need to advance I plus 1, j plus 1. So it would be something like this. I think still I'm unable to explain it properly, so I need more time. Okay, let's code it. Otherwise, we won't be able to complete this problem, or we won't be able to solve it within 20 minutes. 20 minutes. Here we go, bro. We have number and we need two variables. Let's call them. Okay, what I'm thinking. First, we need to find out this non-zero. Can I solve it in one while loop? So I'm thinking about it. Otherwise, I have to use two loops. First, we need to find out 0, first non-zero, then we need to advance index. So I don't go. I will solve it in using single loop. For that, what I'll do, what I'm thinking about it is like something. I'm getting angry. Maybe if I not equals to, if EL not equals to 0, then this is the problem I always face. I stuck in between and I'm trying to approach with different concept or different strategy. Everything messed up. Let me take example again. We can't lose hope. At least. Oh, sorry, my bad. I'm not sharing my screen. The one. Oh, what is this? Be cool. Be always cool. You will be able to solve problems. Problems are every problem comes with solution. So we'll keep hustling, keep practicing. So here we have 014052. 014052. Now, okay, let me take one loop. I equals to 0, j equals to 0. If I nothing but 0, I equals to 0. Okay, let me think about it. First element, what we need to do. Suppose this is 0, then assign it to I. Hmm. And in second iteration, and j equals to I. Okay, great. Second iteration, j will be this one. If you can see me, I'm sweating. I'm feeling like I'm a loser. 0, first element. Actually, I just wanted to solve it in single loop, single while loop, and for that I'm just thinking, how can I approach? If element is 0, that means we can allocate it to I. That means, yeah, if non-zero, we can move on to another number. What if I'll take I equals to minus 1 and j equals to minus 1, and when we are at this number, so we found first non-zero, otherwise both will be minus 1 for at a starting. So when we found first 0, Suppose there is one number 1. Let's say here are we. Then see if we have non-zero number, then we can, and if I equals to -1, that means we don't have any number to swap, so we can move on to next number, that is 1. Okay, here we found like it is non-zero, so keep on going. This one non-zero, uh, keep on going, continue, and here we got 0. Then I will point to this one number, and j will be -1. That means we don't have any number to swap so far. So we'll move to next number, and we'll see if we have any number. Yeah, we have a number. Then what we will do, we'll swap these two. And what we can do now, so we say one we will swap 5 will 0. Okay, and we can advance the value of this number. So still I'm not confident enough to whether the approach is correct or it is not correct. Let me take few more examples here. Man, can you just close? Okay. 00013 minus 2. So we suppose we have 0 0 0 13 minus 2. 0. So we'll store it to I, and we'll look for another pair where non-zero number is there. Okay, what I'm thinking. Let me solve it, but I'm unable to explain it properly. So bad. So let me take I is nothing but -1. So we are at a starting, we don't have an index for 0 or -1, and j is nothing but we are going to look for -1. So index, why this is, okay, so j, sorry. Okay, so here it will be the index of what, j will be index of non-zero, and I will be index of 0. Oh, add time 10 minutes. My bad, I did wrong thing. While, let me take one more variable, that will be 0. Okay, let me do one thing. idx and el in enumerate nums. Okay, we don't need. If el equals to 0, idx, okay, el equals to 1, n- not equals to 0, and okay. So what I'm thinking, element is non-zero, and we have, if I not equals to -1, that means we have something to swap. So what we can do, okay, so I'm approaching with same. I'm not going to solve until I'll be able to I believe it's not going to help me, at least for the time being. Okay, let me see the example again. 014052. 014052. Let's jump to the good notes again. So, first step. Actually, we need to let me note down the steps, and this time I'll try to formulate it if possible. Iterate through each element. Okay, and now element can be 0, can be 0 or non-zero. If it is 0, then what needs to be done? If 0 and we don't have any 0, okay, so here we are assuming like we have two windows, non-zeros, and we are making it like zeros. Something I solved. Dutch national flag? No. Okay. Non-zero and 0. So initially non-zero will be empty. Okay. Now we need to basically this is mixed values. So every time we are getting number, we need to put it in the non-zero field. Again it to non-zero. Again it to non-zero, and ultimately these numbers will be shifted towards the end. And non-zero boundary of non, so okay, so here non-zero is nothing but the index of first zero. So initially it will be -1. If 0 and I equals to -1, then I is nothing but index. Index will be this. Else there will be another scenario if non-zero number. If I equals to, okay, let me call it non-zero, and I equals to no, not I, yeah, I equals I not equals to -1, then swap both and advance swapped both. Okay, so here I think now I'll be able to solve it properly. So yeah, I don't think we need to take just to it that when we first index of, okay, leave it. I'll explain it. I'll try to. So if element equals to 0 and I is equals to -1, I equals to index, that means we don't have any numbers so far uh, where value is 0. So we can assign it as a first 0, and else if, okay, if el not equals to 0 and I not equals to -1, that means I is not -1, means we have zeroth boundary, or we can say boundary where zeros are starting, from where zeros are starting. So we got two pairs to swap. So we'll do swap. Swap means here what we will do, basically nums of idx, sorry my bad, yeah, index number and comma nums of I, and we have to swap nums of I comma nums of idx. Numbers will be swapped, and that way. So now we need to advance the index of the number that we have, because we have filled the last zero with the non-zero. So we can say we have to shift boundary of 0 to next index. Yeah. So here I will be nothing but plus equals to 1, and I believe we will be able to solve. Do we need to, this must be done in place without making any copy of array? Did they mention like we don't need to return anything? I don't think we need to return anything. Try. Okay, great. Exit. We are good to go. Oh my god. I'm able to solve it for the first time. Congratulations to 1 minute. What the heck is this? Okay. So on May 25, no, 2025, May 15th, I was able to solve it. Now, second time I'm able to solve it, but I took little bit more time, but that's not a problem until I'm able to solve it. So that's great. Cheers to me. And let's move to next problem, that is left rotate array by k places. Actually, yesterday I solved rotate an array by one place to the left. I'm saying incorrectly. So you have to rotate an array to the left by one place. Now here we need to rotate it by k place. So that means it now it is dynamic. So okay, let's move to it. Actually, I solved these problems, so I remember the approach. I believe still I'll be able to handle them. But problem will be the main issue will be when we will solve difficult problems, medium problems, and hard problems. I never solved, if you see. So I need to take help, or maybe I'll take time to solve them. Might take 1 or 2 hours, but these all recordings will be for me. So okay, great. We have given an integer array nums and non-negative integer k. Rotate the array to the left by k steps. To the left by k steps. K can be 1 to 10 raised to power 5. And we do not know. Suppose the length of array is k, n, and k is greater than n. Okay? In that case, we need to first divide this number so we can get the exact rotation. Before doing anything, let's note down the example. Okay, this is the second example. Let me take first example. So we have 1, 2, 3, 4, 5, 6, and k is 2. So basically the numbers will be something like I know the uh, one approach is you can use another array and then solve it. We can say brute force approach, but that's not going to be accepted by interviewers. So here we can't solve using that. So we need to do it within array without help using any other another array. Okay, for that what I'm thinking, maybe first let's solve the problem of k. How we are going to, because it might be the value of k is more than the length of array, might be. Then we need to sort out. So suppose the length of array is 2, 4, 6, 6, and we got 8. So 8 is nothing but 8 by n. So whatever is remainder, 6, 2. Okay. So we just have to remember. Suppose here we are going to do, we are replacing it with 3, 3, 6. Then first number will be here. Second, this one will be here. Third will be here. Fourth will be here. And sixth. So 6 by 6 is nothing but 0. So we don't need to do anything. Okay, here I have to think about it. How can we solve it? We have to shift the numbers to the left, to the previous. Was I able to solve it in the past? Oh, July 1, 2025. May 11, 2025. Bro, why you took so many times? Let me take time off timer. Let me start timer. Maybe for, let's take 30 minutes. I believe I'll be able to solve in within 30 minutes, but let's see. Okay, great. So here we go. We have a number. Now we want to shift it towards left by k places. So let me think. Suppose k is 1, then how I will approach? We can do, we can pull this number and store it somewhere. Okay. Then start shifting the numbers. This, this, this. But what if we have two numbers? We can't take out these two numbers and then start shifting. Okay. Okay. So can I say every number is going to be placed? So suppose this is ith number, then it will be ith I minus k. Yeah, but only for the numbers that are greater than k. Greater than equals to k, and 0 to k minus 1 will be oh my god. Why I feel like we need to use some sort of sorting for to solve it. So here we need to do one thing. First, reverse these k places, change them to 2 1 and 6 5 4 3. 6543. Yeah, great. Now reverse complete array. 3 4 5 6 1 2. Yeah, I got it. So I think I remember it. That's why I'm able to solve it. But is it the right approach? But here how I'm going to approach it, then that if that is the case. Okay, we are not using any sorting technique here. Sorry, my bad. That's why I thought how can how they can give a sorting problem at the starting when we are just starting with basics. So okay. So first we need to sort 0 to k, reverse, and then 0 to minus k minus 1, and then k to length of array, and then complete reverse complete. So it's better if I'll use any function to reverse the number. So let me create another function, diff reverse. I believe we have reverse function here. But we need to use it differently. Let me see if we can use something with index and all. Then we will use delete it for the time being. So let me ask how much time remaining. 24 minutes. ChatGPT, no. Google Chrome, yeah, okay. Python reverse function. I know I can use slice operator. Okay, let's build our own function. Resume. Let me call it diff of reverse function reverse array, let's call it, and self comma nums will be array start and end. Okay, so we have two things here. Okay, here I can see they have used type notation, but we don't care about it, at least for the time being. So what we will do, start and end. While start, basically start is less than equals to end, less than end equals to, we don't need reverse. So nums of start and nums of end swap with nums of end nums of start. This is the best thing I can say in the Python. To swap two numbers, just write simple syntax and it will take care of everything. So great. They did lot of they removed lots of boilerplate code. They removed lots of boilerplate. So basically they removed lots of boilerplate code. They removed lots of boilerplate code. Okay, so we reversed this, we swapped the number, and now we need to advance num. Okay, start plus equals to 1, end minus equals to 1. Okay, so we did this. Now we have two numbers, and so I finally we reversed. So now we have to reverse first k, reverse last n minus k, reverse all. I hope I haven't made any mistakes so far. So reverse, let me call it reverse array, and num self, maybe we need to call it like self dot reverse array, and here zero k minus 1, and here self dot reverse array nums k and nums dot len of nums minus 1. Okay, great. Self dot reverse array, but I'm thinking, what if I'm unable to recall this method? Then how will, but this is not a method, bro. 0 to k, 0 to nums len of nums minus 1, and here we go, we did it. Okay, 1 minute, bro. I think I'm not. Okay, let me take corner cases. What if there are, okay, we forgot one more thing. K is nothing but, okay, let me do one thing. N is nothing but length of nums. So here we can reduce it, remove it, n minus 1, because otherwise we are again and again calling order of n. So n minus 1. Okay, k is nothing but k n percentage by k, whatever we have remainder, that is nothing but, so if it is, oh my bad, k percentage by n, that means if number is greater than k, then it will be, it's just going to return the remainder of it. If it is less than n, then it will be the same number. So k, we got k. If k equals to 0, return nothing, we need to do. Okay. Okay, great. We are able to solve it. So let's now calculate the complexity. So here it's order of one operation, order of n operation, order of n, order of 1. This one is also order of 1. Okay. This one we can assume. Suppose if the value of k is nothing but n minus 1, then we can say order of n, right? So order of n will be it will be order of n, not it will it be something wrong. So this one also we can say, if we can say it order of n, suppose k is very small, then the remaining numbers will be order of n. So yeah, this one order of n completely. So here we can conclude, and here we are taking, so yeah, it's nothing but whatever we are calculating, it's nothing but it depends on start minus end, so we can assume it's order of n. And now let's move to another problem. So we are able to solve it. Time remaining, what remaining? 6 minutes. But here why it is saying, yeah, so we solved this one, left rotate array by k places. But what I'm thinking, it's been more than 1 hour and I'm able to solve only 3 problems, that and with these problems I already solved in the past. Remove duplicates from sorted array. Let's see. Actually my problem is I'm unable to remember, I can't remember the problems. So whenever I see a problem, it feels a fresh new problem to me. But this time, even this time, I'm not going to read, or maybe I'm not going to remember these problems because it's difficult for anyone. If you are doing ratta, then I don't know. Otherwise, it's for me it's very difficult to remember the problems. So we need to learn pattern wise. So after solving the basic problems, we will approach with patterns, because most of the people are now suggesting to proceed with patterns. Otherwise, how can you solve thousands of, there are so many problems, you can say there are more than thousands of problems in lead code, and it's very difficult for anyone to, at least for me, very difficult. Okay, so let's move to problem number 4. And here I think let me target this problem. After that I'll solve these problems in the morning. So 4 in the morning, 4 in the evening, and it's like 2 hours of practice daily. That is not sufficient, bro. People are taking completely to solve the problems. What I'm doing? Just getting frustrated. With what? Okay, so remove duplicates from sorted array. Got it. Sorted array, we need to remove duplicates. Given an integer array nums, sorted in non-decreasing. Non-decreasing means sorry. Non-decreasing means increasing order. Increasing or equal or increasing. So non-decreasing, that means either numbers are equal or increasing. in place. Suppose 0, 0, 3. So 0, 3, 5, 6. Okay. So I was thinking like I'll just count the district number, but here they are going to check it. So basically, we need to remove the duplicacy, or we need to shift them at the end. So they don't care if you are going to shift or whatever, how you are going to tackle them. So let me note down the numbers first. 0. Let me change the color. That is ugly, at least for. So we have 0, 0, 3, 3, 5, and 6. And here we go. Bro, quick time player. Okay, what we can do now, or what we are going to do. So I'm just thinking about it. We have 0. So first number, it is okay, great. Second number, we'll check with first number. Are you correct? You should be removed. So it will say, yeah, I don't need to be here. You already covered one. Or we can say, it will say, bro, my brother is already there, so I don't need to be here. I'm not a right person to sit here. So just pull out me. Imagine these all people are sitting in the row and there is a condition like no, these all are twins. If there is so these are twins and another are single child of mother. So not single child of mother. Basically they are not twins. So these twins there is condition only one can sit here. So another one have to leave the row. And another one to lift left the row. So 0 it will be saying no I can't sit here. Then okay, so what I'm thinking here also we need to approach with two pointers only. Basically, let me tell you, or let me think more about it. First number, it will say, okay, let me see the constraints. What are the constraints, bro? Can you just sort oh, what I did? Just close Chrome. Sometimes some weird things happen. Here is array. So length can be 1 to 10 raised to power 5, and number can be negative as well. Could be positive, negative, anything in non-decreasing order. Okay. So we'll start iterating from second element onward. Okay, and we'll store it as a last, so we can check whether the last element is similar to the current element, or yeah, the current element. If so, then we need to swipe it, or we can say yeah. So here we found it. Mhm. Or okay, what I'm thinking, this is the right element now. So let me call it as a right. So right means it's correct one. Now we are in this element. We can check this element whether it is right or wrong. If it is equal to the last, okay, so not right. Basically, if it is equal to right, that means we already have this element. Otherwise, what we can do? So still, I'm unable to explain it. I can get it. I got it. I got the solution. I mean, I got the approach, but I need to think more how I'm to how I'm going to explain it to you. So let me say this thing. Here we are taking this as a window where we have good element. Okay. So first thing what we will do, will include first element as a good element. Okay. And let me call this index as the last index of good elements array. Last. Now we will start from here onwards, iterating through each element, and we'll see are you equal to last means yeah. So this one is yes. Then we will simply discard it. It will say ask, are you equal to last? Yes. So remove it. No. So what it will do? It will say okay, you can be part of my array. So I'll give you a space. So here it will say okay, you can. So it will say my position is last. My position is nothing but last index, and there is an empty space after me, so you can fill that space, because if someone is there, just we can kick out. So it will say last plus one and go there and swipe it and sit there. So it will do, it will sit here, 3 will be sitting here. Now we will do one more thing, that is we need to update the last, because now this is the person who is sitting at the boundary. Okay, let's move to next number 3. It will again ask, bro, are you equal to me? It will say yes. Then just go to hell. Okay, now it's turn to check the number 5, and it will again ask, bro, are you equal to me? It will say no. Okay, welcome to the unique elements array, and it will be placed. It will say, okay, I have space, or maybe you can sit on balcony or whatever. And again, same approach with it. So we got it. So how we are going to solve it? So now we got the problem, we got the solution, and now it's time to approach it. So what we will do? first thing first thing what we will do, okay, simply store the last value as the go- index of the last element of good array. We are calling it as a good array. This one is we are calling as a garbage. So we are pulling the good candidate from garbage. Okay. So we will keep last as 0 first index, and after that we will move forward and will expand the array. Okay, I'll solve this problem only for the time being or for the today. It's done. So okay, let me last nothing but 0. Okay, we are just storing index, and here we go for I. Yeah, let me call it as index and el in enumerate and list. Sorry, my bad. Nums. Okay, I remember one more thing here. We are starting from first index onwards. So here, last time I forgot it. Okay, now we have numbers. If okay, nums of last equals to el, continue, else last plus equals to swap. So swap is nothing but here, and nums of last plus 1 is equals to comma nums of idx is nothing but nums of idx, and nums of last plus 1, swap these two numbers. Even we don't need to swap it, so let's do one thing. Simply we need to fill it. So nums of last plus 1 is nothing but we can fill the value with good value. We can fill the good value or the first best candidate. So nums of here we can use el. So then we don't need to I believe then we do not need this one, and we can simply iterate through. Yeah, we need to remove the things that are not necessary. Unnecessary, we don't need to take any burden. 1 onwards, slicing, and here slicing, dicing. Great. Okay, so this is done. Or what? We need to do one more thing. We need to index advanced last plus equals to 1. And now we are done. Okay, here we need to return the number. So can I say initially it was this one? So we are advancing. Now we are at last plus 1, and last will be last plus 1. So what I'm thinking, we do not need to do 2 times operation. Let's do last plus equals to 1, and last we are going to swap it. And we have length return last plus 1. Oh man, plus 1, and I hope it is going to work. Try it. Let me try to submit it. We solved it on May 12th, May 12th, 12th, 12th. Inconspicuous. I'm fumbling. Will rock. So we solved it, and let's see the complexity of it. So it's something but you can see order of n, 1, order of 1, order of 1, and it's like n times operation iteration is happening, so order of n. So I think this is good. We solved how many? Okay, here we go. So done for the day, and we'll start tomorrow morning. I'm hoping I'll start tomorrow morning. Otherwise, I'll in the evening. I just wanted to face these easy problems as possible, quick as possible. Then we'll jump to the medium problems, and if you can see, there are total 12 problems, and I already solved only 8 out of 12. I think with the help of tutorials and all. So we need to work a little bit more on these problems. So done for the day. Bye guys.